Hello, my name is Poeschko. I work for Wolfram Research, and today I'm going to talk about cloud notebooks, what you can do with them, and what we've been working on over the past year. Hello and welcome. My name is Jan. I'm the lead developer of the Cloud Notebooks team at Wolfram Research, and today I want to show how to develop sort of a whole application using the Wolfram Cloud. And of course, I'm a bit biased, but I thought it would be nice to make extensive use of cloud notebooks to do that. There's many other ways how you can create content and develop applications in the cloud, like form functions and API functions. And I think they're very good stuff. They're very powerful, but I think also pretty straightforward to use in a sense. Whereas with cloud notebooks, I think it might be a bit surprising what all you can do with them. And so my idea was to build a blog, basically you could call it a static site generator built with the Wolfram language that takes some content that in our case will come from cloud notebooks. So that's how you as the blog author would write your content, however you want. And then it would take that and also deploy it again as cloud notebooks, just in a slightly different form. So we want to add an index page that allows you to navigate from the landing page of your blog to individual posts. And then we'll have a navigation header, and we'll also take care of comments so that people can comment on your posts. And that will be quite a dynamic aspect to this. So just to give you an idea of what we want to build in the end, here is the final result. So there's a header up here. You have a list of posts. You can click them, navigate around from one post to another. Here's some comments. So yeah, that's what we're going to build here. And again, the idea is that we go from what I call source notebooks through the code that we'll talk through here to target notebooks and some stuff around them. Yeah, so it's going to be quite a deep dive into actual code. So please bear with me. What do you have to do to get started here? We need to decide where to put all this in the cloud. And there's the concept of unnamed cloud objects, which you get by default when you just do a cloud deploy of a manipulator or something. But for everything that's sort of more persistent that you want to share with other people and maybe update later, I really recommend using named cloud objects. So in this case, I just say my blog, and that will represent a cloud object that lives in my home directory on the cloud. I could use subdirectories here, whatever, but this is not just representing the thing under my home directory. And then, so that's where the blog will be accessible in the end. We also need to decide where our content lives, so the source notebooks. And to make it easier, I just decided to put that in the same directory under a subdirectory called content. And there is a convenient function file name join that also works on cloud objects. So if the first part in the list is a cloud object, then file name join will create another cloud object doing the thing that you would expect. And this is a general theme that might be a bit surprising, but it's good to keep in mind that various file-related functions also work with cloud objects and just do the right thing with them. In the end, we need to make that an actual directory. So also something to keep in mind, cloud object itself, the function is only the representation or the sort of the address of that object. It doesn't mean whether it exists or not. So at this point, it doesn't exist yet, but once I do create directory, now it will be an actual directory, and also the parent directory will be created automatically. Okay, and then, so we have the source directory. We don't have any actual content there yet. I could now go and write stuff either in the cloud directly or in my local desktop Mathematica. In this case, I have already a notebook there, just in the same directory as this notebook for the presentation. I'm just going to copy that into the cloud. And again, I'm using a function copy file that was originally meant for files. But now, if the second argument is a cloud object, it just copies the thing into the cloud. Another way, just to give you an idea, to get stuff into the cloud is, of course, cloud deploy. So if I do cloud deploy of a manipulate, and then as a second argument, again, a cloud object in this directory, then it will deploy that to the cloud. I can already click the link, and yeah, that's what it is. And this is also interactive now. Yeah. So that's our source objects, and you can already see that I've used this sort of naming convention here that I'm going to make use of later, where I basically say what the date of the post is right in the file name, and then the second part is the actual title of my blog post. Okay, so given that, we need to decide what our target objects are going to be, and we'll almost keep the URLs the same as the source objects. We'll just, make them a little simpler. So we take the base name, so the name of the file itself from the source object, and then we remove any diacritics, we convert it to lowercase, and then we replace any spaces with dashes, which is what you would sort of expect in final URLs. And I would just like to point out that here we make good use of very nice features in the Wolfram language to easily work with strings and so on. So we have all that power that's useful here. To get the title of a page, we just extract the thing after the last dash, basically. So we have these helper functions, and yeah, then we can start thinking about building the index page where you can see all the blog posts listed. To get to these, we just use a function cloud objects that enumerates all the objects in a given directory, in this case the source directory. So that's the two objects I just created earlier, of course. I'm only using a set delayed here so that we can easily reevaluate everything later and it will update automatically. Same for the index object. That's where the index page will live in the end. And then we'll want to build the notebook that constitutes that index page. So here it's all about working with the symbolic structure of notebook expressions. So for each blog post, we want to create a cell that has a hyperlink, pointing to the target with the title that we already have our nice functions for. And then we just need to wrap that in a cell, and there's a bit of boilerplate to create actual box content. And then we're almost done for the index page. We just need to wrap that in a notebook head and deploy that, where deploying means, in this case, just using cloud export of the notebook expression. Tell it again that this should use the notebook format, and to my target object. And then I say that the permission should be public because I want everyone to be able to look at this page. If you execute that, given the sources that we had before, it will create this page. Doesn't look very nice yet, but it does have the two links. Let's make this a little larger. No particular reason, actually. I think I just wanted to highlight that you can use both. Cloud deploy would have worked just as well here. There's sometimes, and maybe this is going to change. I'm not sure if it's true anymore right now, but cloud deploy of a notebook used to do some sort of magic that decided if it's not actually dynamic content, it would create a more static version using static HTML, and that looked a bit differently than an actual notebook. So basically, if you know that you want an actual notebook, then Cloud Export is a good choice, I would say. Right, so we have the page here. Of course, the links don't work yet because we haven't deployed anything yet at the target objects. One thing I can already show is that there's a good reason I chose index.nb, because that will allow us to even omit that from the URL. So I can just do that, and it will pick up index.nb automatically, similarly to how you have index.html, which would also work, by the way, if you have a static HTML page, but it does the same for notebooks. Right. So the individual posts. There's a bit more code here. We need a way to extract the date from a given file name, with the dashes that we had. And then we create a cell based on that date, because that's what we want under the title of every post. We want to show the date as a subtitle cell in this case. And then to add that, again, we make use of the symbolic nature of notebooks. We just find the first cell, which is a title cell, and then we inject our date cell into the notebook at that position. There will be probably many different ways to do that, to operate on these list-like structures, but yeah, that's one. We also want a cell at the top where we can navigate back and forth between posts. So we just have a function that gives us the previous one and the next one, and then constructs hyperlinks based on that. Similarly, we then add that at the very beginning of the notebook. And then to assemble a final notebook, we just call these two functions. And of course, it depends on the original notebook content. That's what the post will be all about. And to retrieve that, we just use cloud get here. In general, cloud get is used to retrieve any expressions from the cloud. In this case, we make use of the fact that a notebook file is nothing but an expression in the end. So that will give us a notebook expression, and we modify it in this way. Then again, to deploy a single post, we just use the deploy notebook function from before. These were the little helper functions to get the previous and next one. And then we create a function to deploy everything, but just deploying the index page and the posts. And I would say that that's a very useful scheme in general. If you create a cloud application, make sure that you have one function that allows you to easily deploy everything at once. So you don't have to worry about which parts did I now update, did I deploy the right things to the right places. Just make one function and really relying on the power of Wolfram language again, that makes it very easy. So now we have, and by the way, I made it return the URL and also the number of posts, just so I can see immediately what went on. So now we have everything here. I can now click on this page. And as you see, we have the title, we have the date, which was not in my original source notebook, and I have a link here to jump to the next post. Takes a little bit to load, but yeah, there's the manipulate. All right. Any questions so far? Good. Next thing, let's add a header to make it more like a real website. For that, we can be as creative as we want. I just decided we want a hyperlink to the main page again, and you can do some styling, give it a background and some cell margins. So that's it. That's what it's going to look like. Of course, it also works in the desktop front end. But now we're going to deploy this as part of our posts by just setting the docked cells option. That's a useful thing for anything that you want at the top of the notebook, and that stays there even if you scroll down in the notebook. And I'm also, while I'm at it, hiding any cell brackets, because that seemed a bit odd here to have the brackets in a published blog. we just changed the function that we had before to deploy a notebook by now using these notebook options. And then I'll just redeploy everything. So now we have the header. I can go here and click it again to go back to the index page. All right. On the index page, it still looks a bit lame just having these single links here. So I thought it would be nice if we styled this a bit and also included sort of a summary of each post on the index page. And to do that, again, it's just working with the notebook expressions. So to get the summary, we get all the cell expressions out of the notebook, then delete the title cell, take up to 3 cells from the remaining ones, append that to the hyperlink that you already had before. No, actually append that to the title cell, and then also add the read more hyperlink at the very end of the summary. So yeah, that's the summary, and then a single index entry is just the hyperlink that we already had, plus that plus the summary. So with that, it now some cache, I guess. It looks like this. Oh yeah, right. There's the read more and 3 cells, just as you wanted. All right. Now is probably the trickiest thing, the comments. How do you want to deal with that? So again, the idea is that there's an input field on each page where users can type something and press a button, and then that should be added to a list of comments. And of course, you want to store these comments. So if you revisit the page later, they should still be there. There's a couple of ways how you could store these. You might think of using a single cloud object containing a list where you just dump stuff into it. That would probably work well enough for most cases, but it does have a problem with race conditions. If 2 users at pretty much the same time would make a comment, it would try to write to the same cloud object at the same time, and then one would probably overwrite the other. We are thinking about locking mechanisms for cloud objects in general that would prevent that, but for now, it just wouldn't be the best idea. Other options would be using cloud expressions, but that's still a rather experimental feature, and I would not recommend it for anything that could grow very large and that you don't want to lose. And also, you might think of a database. I think there's great integration coming for databases in Wolfram language, so then you could connect to a database server. But for now, what I decided to do is just to store each comment in its own cloud object. Very simple solution. We just have to decide on one directory where we put all that stuff. In this case, it's going to be inside the blog directory under comments. And then there will also be a subdirectory for each post, and then the individual comments will just be cloud objects in that directory. So create that, and then this is, I think, the longest function here. It still just fits on the screen. What do we have to do for the comments? It's gonna be basically a single cell that contains a form. I don't mean a form function here, but really just an input field and a button. We can see that here. So there's an input field with dynamic, so I have access to this variable, and then the button just says add the comment, whatever the user just typed. All around this is a dynamic module, which on the one hand localizes all these functions that I'm defining here, and by putting those functions into the initialization, and make sure that whenever someone opens the notebook and the dynamic module appears, that these functions are actually available. You can't assume that the kernel already has these predefined somehow. They need to be defined when you open the notebook. And on the other hand, we keep this sort of local state here, namely the list of comments. And then when you add a comment, so that's this function, we basically just append to this list of comments. And what we store here is just an association that keeps track of the text, the author, and the date. And then, as I said, we also store that in a file, in addition to changing what's displayed in the notebook right now. So for that, we just create a file name again using file name join. I'm just creating a random name here because it won't matter in the end for the individual comments. And I'm using as a serialization here expression JSON, which is just a very general format that preserves all the the expression as such. Right. Then what else? To render a single comment, we just use a panel. And then this is where it gets a bit interesting. So this is the cell that shows the form, but we only want to show that if the user is logged in. So we want to keep track of who posted which comment. And if they're not logged in yet, we want to make them log in using their Wolfram account. And then we can just use $requester Wolfram ID to know who they are. And yeah, if they're logged in, we show the form. But if they're not logged in, then we want to show a link saying that you can log in to comment. And then below that, we just render all the comments. So how is this? How does this work? And this reason I'm showing is I think this could be a useful technique for various cloud applications. How do you make sure that the user is logged in or ask them to log in otherwise? You can deploy a separate API that makes the user log in using our Wolfram provided authentication mechanism. You do that by deploying an API function, or in this case, it's a URL dispatcher, but it's almost equivalent, that has permissions only for authenticated users. That will ensure that when anyone tries to open this cloud object, we ask them to log in first and then redirect them back to the object. Now, in this case, we want one more redirect because obviously we don't want the user to stare at an empty page after the login. So the login API itself just makes another redirect back to the original post that the user came from. Okay, so there's two redirects potentially. And how do we know where they came from? It's just going to be part of the URL. This is a bit tricky, and I probably don't want to explain in too much detail, but unfortunately, I can't use an API function with a query parameter here because that would kind of get lost on the way as it redirects back. But it can preserve the base URL. So I'm just constructing a URL that has the target as part of it, and that makes sure that when our authentication page redirects back to this URL dispatcher, we get the same URL again, and then we can just redirect based on that URL. So that's the login API, and then similarly as before, we have a function that adds that whole comments thing to a given notebook under a section. Did I evaluate this? No. And then we tweak the function that we had before that creates a single post by just adding the comment section. We deploy this. Hope this works. Let's see. Comments. Here we have our input field. Type something. Press comment. Oh, yeah, there it is. So it knew that I was already logged in, and so it just posted that. If we try the other route, if I sign out now, I don't know why this happens, but if I go, oh, wait, did I not? Did I not make this public in the first place, or? Okay, let me try one thing. That's interesting. Maybe that's a bug actually. Or maybe I should have set the permissions on the directory as well. But yeah, so if I access the index page directly, that works even without being signed in. And now, as we see, it detected that, gives us the link to log in. That will redirect to the general authentication page, and then it wasn't even noticeable, but it redirected page back to that login API, and now back to the original blog post, and now I could comment here. Oh, good question. I think there's something with caching. I don't know if it's a browser cache or something, but I think the browser keeps a cache if it redirects and then back. So. All right, so that's comments. A few more, maybe slightly advanced things that you might want to do to apply more styling to notebooks. A useful thing is notebook style sheets. So it's a bit similar to CSS style sheets on the web. But in this case, we're telling the front end how to style a notebook, and we're doing that using another notebook. So there's this special format with style data cells. You can say that the text style should have certain options. In this case, we just say that any text should use this particular font. And then, so this feature we added rather recently to have support for notebook style sheets in the cloud. You can simply deploy the style sheet or just copy it to the cloud however you want. You just need to make sure that the permissions are at least as open as the notebook that it will be using the style sheet, because otherwise people would open a notebook and they might not be able to open the corresponding style sheet, and then it wouldn't work. So in this case, we just set it to public, and then to use it, we again change the notebook options that are used for every notebook we deploy as part of the blog, and we just reference the style sheet using this syntax. So if we deploy now, slow. Okay. Refresh. Now we actually you can notice this, but it's a slightly different font now. Of course, I could have done all sorts of stuff, right? I could change all the colors, maybe the spacing of things, and so on. Okay, but maybe that doesn't cover your use case, or maybe you already are familiar with how to write your own HTML and your own CSS, and at least for some things, you prefer to have that full low-level control over how your HTML should be. And you can absolutely do that in a notebook as well. So what I want to show here is how to embed HTML as part of a notebook that just makes up a single cell, and then the rest of the notebook is regular notebook content again. So for our blog, let's switch out the header basically, and it's going to look very similar to before, just a link to the main page again, but in this case using HTML and also CSS that I wrote before. So to give you an idea how that looks like, it's just some piece of CSS that says background and so on, which we also need to copy to the cloud. And then instead of the docked cells that we had before, we now have a cell that contains embedded HTML. What's usually very important with embedded HTML, and it's unfortunately not documented well yet, is that often you need the image size option. By default, it will try to figure out automatically how large the content is going to be, but that doesn't often work very well. So it's usually a good idea to just say what you want. In this case, I want it to span over the full width and just have a height of 50 pixels. Right, the rest is just boilerplate. I also don't want any margins in that cell to really have the HTML make up the whole thing. All right, refresh again. Is it? Yep. You can tell by the hover effect, this is now using our custom HTML that we wrote. If we look at this in the browser's dev tools, you find that HTML code again. And it's also good to keep in mind that whenever we use that, it is actually using an iframe to isolate things from the notebook world from the HTML world, not least for security reasons. It does not. No, I mean, it doesn't crash everything, but what will happen is I think you just get a button that, so if I do, I don't know, does blink still work? Oh. It's not a thing anymore, but what happened is I got a button that allowed me to open that in a browser. I mean, obviously you would only use that if you're targeting the web, so to say. If a notebook is good enough, and I think for many cases it is good enough, then just use notebook constructs. If you want to use HTML, then that will only work on the web. I think this might also change at some point. There is some ideas of how to integrate WebKit into the desktop front end, and it could potentially render this, but right now that's not working. All right, and then this is getting even a bit more advanced, but some people have been asking about this, so I thought I'd show it. So this is about interacting with notebooks from other websites. It could be either from embedded HTML inside the notebook, and you want to click a button there and have it affect something in the notebook, or maybe from an outer website where you embed a notebook that just shows a bit of content, like maybe a manipulate, but outside you have your whole website that maybe you already have or are building. So you want to be able to kind of reach into the notebook somehow, and also maybe in the other direction, get something out of the notebook again. For that, I prepared a separate notebook. While I was working on this, I did unfortunately discover a few bugs. I mean, most of it would still be working, but I had to fix something. So this is now using my local private cloud. And there we have this notebook. So yeah, this in a few weeks, this should also work on the public cloud, or all of it. So let's start with the direction where you want to control the notebook from some JavaScript code, let's say in embedded HTML. So what we have here is embedded HTML that contains a button and calls a function. And in this case, we want to open or close a cell group. And we can do that by calling this function. So this is automatically provided for any embedded HTML and any JavaScript inside there. You have access to wolfram.cloud.parent notebook, which is the notebook containing this piece of embedded HTML. And then there's a function there called evaluate expression, and you can just give it a string that executes this more or less arbitrary piece of Wolfram language code. And then there is, again, a Wolfram language function that opens or closes a cell group. So yeah, then that's all we need here. Yeah, we just inject the definition of that function in this case, to make it more convenient. I will show how it works in a more general case as well. So just to demo that, if I now select this cell and then press the button, it will open and close the group that's containing this cell. Okay. There is a sort of caveat to that. This only works if this is what we call a safe expression that can either evaluate right on the client side, because I believe that this doesn't even have to go to the kernel. It will actually evaluate right in our JavaScript evaluator. But if it needs to go to the kernel for, let's say, some complex math operation, and it's not considered a safe thing, then this wouldn't work. And the reason is that we have a mechanism that so that we only allow evaluation of expressions that are contained in the notebook. We don't want a viewer of a notebook to be able to execute arbitrary code that would potentially run in the owner's kernel, because when you deploy a notebook, it's using a kernel that has access to your cloud files and so on. And obviously that would be bad if any viewer could execute anything. So if we want to sort of inject the evaluation of an expression from completely outside the notebook, we need to do some low-level thing to sign an expression, which adds a signature, and then the client will be allowed to evaluate that expression in the kernel. So in this case, if we want to evaluate quit, which is obviously not a very safe thing, then we wrap it in sign expression, do some extraction of that again, and eventually we get a string that looks like this, and then we can feed that into evaluate expression. So if I use that in embedded HTML and now I press this button, it quits the kernel. You could even see it down here, and the cell labels changed. Okay, that's kind of addressing your question as well. What if you don't use embedded HTML, or for whatever reason this doesn't get injected automatically? Then you have to step one level deeper and use what we call the JavaScript notebook message API. It's relying on a JavaScript mechanism called post message that is responsible for passing messages from one window to another. And that's usually, a containing page sends a message to an iframe or the other way around, even though they might be from completely different origins, so they couldn't just execute JavaScript in each other's context. If you embed a notebook, then you know what that window is. You would somehow have to get a handle on that iframe and the window that it contains, and then you can post a message to it. So that's the way. There's some boilerplate. You say what API and version and so on, and then you use this command, and the rest is the same as we saw before. You just pass in an expression. That's all you need to evaluate something. If you also want to get back a response, which is interesting in this case also for other API commands, you get back a message to your window from the notebook window. So you have to add an event listener for message events, and then you can extract the result out of there. We could even try this here. So I'll open the JavaScript console in this browser. And in this case, the notebook window is the window itself. So it's kind of the same window talking to itself. But it should still work. And so we computed sign of pi here, and in the end, alert the result. All right. This JavaScript notebook API has a bunch of commands. We only saw evaluate expression so far, but there's things to manage the cell content and the selection and so on. It's unfortunately not officially documented yet, but I think we'll hopefully get to that soon. And yeah, maybe, of course, longer term, maybe we won't even need that many operations on this level, because ideally all you would need to do is evaluate an expression, and since you can do everything in Wolfram language itself in terms of notebook programming, that might be enough anyway. All right. If you're still with me, I can also show the other direction. What if we want to send a message from notebook to some JavaScript code that's, again, running either outside of the notebook or inside some embedded HTML? In this case, we have embedded HTML that basically uses, again, this window messaging mechanism. So we install a listener, and when we receive a message, we change a counter and update what's displayed here. And we just came up with this function called post message that does just that. So in this case, we have a button, and when I click it, simply sends a message to all the iframes that were created by embedded HTML, and the listener inside can pick it up. Yeah, very low level, of course, but if you're integrating notebooks into some website, that might be just what you need. Similar, you can send a message to the outer window, so not the embedded HTML things inside, but something outside. And I should note that this function by itself only works in, again, what we call the client-side evaluator. If you want to execute it in a kernel evaluation, then you need to wrap it into front-end execute. So if I want to shift-enter evaluate this, then with this wrapper, it will also work. Finally, just this one little thing. We had this function deploy that deployed our whole page, but I can make this as convenient as I want for me. So if I want to edit my notebooks in the cloud, and then I want to update the whole blog without even executing any code directly anymore, I could just deploy my deploy function in a delayed under a certain update URL, and that whenever I open this cloud object, it will run my whole deployment code. Takes a little bit, used to be faster, but it should come back and then again give me the URL and the number of entries. So now I could bookmark this page and just press it in my browser and be done. That kind of makes use of a lot of magic of Wolfram language under the hood again, right? Because it pulled in all the definitions that I made before, all wrapped them up in a nice API and exposed that. And I also want to highlight, how we've been using notebooks here. So when you think about it, really kind of amazing that we've used them for so many things. We used notebooks to define our original content that was used to populate the blog. We used them as a deployment target to kind of create websites without really writing HTML at all. I used notebooks when I wrote all this code before. We used notebooks to define style sheets. We created notebooks to style other notebooks. And of course, we're looking at a notebook here for this presentation. So it has many faces, and the reason it all works so well together is because of this underlying symbolic structure of notebooks that also integrates so nicely into the symbolic structure of Wolfram language itself, which is kind of unique, I think. This is online in a slightly streamlined form on GitHub. And if you have any questions, let me know. Thanks.